So about 50 years after Dalton proposed his atomic theory, there was evidence that atoms were divisible, that atoms themselves contained smaller particles. And so these are called subatomic particles. Sub meaning below. They're below the size of an atom. So subatomic particles. The first two that were discovered were electrons and protons. Electrons have a negative charge. They can be measured in coulombs or other units of charge, but chemists don't typically care about that. And so we use a relative charge. We just say an electron has a relative charge of -1. The proton has a relative charge of +1. So they're essentially the same amount of charge, just opposite in sign. This is the symbol for the electron, E with a superscript negative, because the electron has a negative charge, and the proton, sometimes we put a plus, sometimes we leave it off. But it's important to remember which one's positive and which one's negative. Proton starts with P. Positive starts with P. The proton is positive, so the electron has to be the negative one. So 1903, a century after the Dalton's law, or Dalton's model of the atom, J.J. Thomson came up with his idea of what these particles looked like. So they had evidence that there were these particles, but then how are these arranged inside of an atom? Atoms are too small to see, and the particles inside them are way too small to see. And so he said, well, I think maybe there's these negative electrons, because they were pretty sure those were discrete particles, and then the positive stuff might be just kind of evenly distributed around the whole atom. And so this is called the Plum pudding model. J.J. Thomson was British, lived in England. Anybody ever had plum pudding? No, most Americans haven't. So, because when I think of plum pudding, I think of like vanilla pudding with plums in it. And like, why would you do that, right? Plum pudding is really more like a bread, cake-like substance with plums in it. And so it's better for Americans to think of a blueberry muffin. Okay, so blueberry muffin, everybody seen a blueberry muffin? Whether you eat them or not, it's, I don't care. But we know what a blueberry muffin is, right? You got this white muffiny part, the bread part, and then you've got blueberries kind of stuck throughout. So that was his model, his idea of what the atom looked like, what the electrons and these protons looked like. He said, well, this positive is just kind of the spread around. So Thomson did some experiments. I feel like I'm skipping something, but maybe not. No. He was actually able to calculate a mass-to-charge ratio of a proton and an electron. And a few years later, another guy, Robert Millikan, was able to figure out what the charge on the electron was. And then because Thomson knew the mass-to-charge ratio, Millikan provided the charge, then Thomson could figure out what the masses were. And so these are the masses. An electron has a mass of 9.11 times 10 to the minus 28 grams. Is that big or little? That's little. We can't even conceive of how small that is. So that's a 0.27 zeros, 911 grams. And a gram itself is a small unit, okay? Tiny. Okay, proton, bigger than an electron, but still mind-bogglingly small, 1.67 times 10 to the minus 24 grams. Now, chemists do not use these numbers much, but occasionally in homework or something, you'll find a problem that's wanting you to calculate the mass of something, and you might have to look numbers like this up. But you do not have to memorize the mass of an electron and a proton in grams. Another guy, new section.